Hello everyone, in today's class we're going to look at a manometer example, or also called a YouTube manometer example. We'll start with the center line. This is point A. I usually like to start solving from the center of pressure. Okay, we'll assume that the liquid here is water all the way up to this level. Okay, and so this is water, specific weight of water. This here we'll assume it to be air. Okay, and it goes all the way to here. From that point, this is water again until this point. And this is an unknown fluid that has a specific weight of G. Okay, but the specific gravity is given to be 3.0. Okay, so you'll use this to find the specific weight of that unknown liquid. Anyway, the unknown liquid goes up until it reaches here, which from that point it's open to atmospheric pressure. Oops. Okay. Now, how do we go about solving this example? So before we start solving, we need to look at the heights. So this is the center line. Sorry, let me just do a quick correction here. The water ends here, and the new fluid starts. The new fluid starts from this point here. Okay. Okay. So the height from the center line to this point, where air ends and water starts, is 1 foot. From this point up until this point, it's 4 feet. Okay. And between this point and where the fluid meets atmospheric pressure, it's 1 foot. Now, when solving a manometer problem, where I like to start from is the center point. So PA. Now, since we're going up from PA, it will be, the pressure decreases as we go up, so it'll be minus. So PA minus the liquid is water and the height is 5 feet. So minus 5 times what type of liquid? It's water, times the specific weight of water. Now we reached this point here. Now, since this point and this point are in the same horizontal plane and they're the same fluid, here it's air and here it's air, then the pressure at this point is the same as the pressure at that point. So we can start from this point and going downwards. So since the fluid is going down, pressure will increase. So it will be plus 5. That's the height of, sorry. 4, air ends here. Always try to start and stop where the fluid changes. So from here, this point to this point, that's air, and downwards it will be water. So plus 4, that's the height, and what liquid is it? It's air. What fluid is it? It's air. So times the specific gravity of air. Now, basically, at this point, the pressure of air is the same as the pressure of water at this point, and that's why it's at equilibrium. If it's not equal, one side will push the other side. Either the air will push the water down, and that's unlikely because air is a lighter fluid. Therefore, water will push it upwards if the pressure was not equal, and that's why they're at equilibrium. So therefore, the pressure of air is the same as pressure of water at this point, and that's why they're equal. Anyway, so we'll start from this point and we'll go down until the fluid changes. So when we go down, pressure increases, so it will be a plus the distance between this point and that point where fluid is changed, it's 1 foot. So plus 1 times the type of fluid it is, which is water, times 1 times a specific weight of water. Now, the pressure at this point for the unknown fluid is the same as the pressure at that point. The reason is because if you take your finger and you go from this point to that point, it's continuous and it's the same fluid. Therefore, we don't need to include all this. We can start right away from this point here because the pressure at this point and this point is the same because it's the same fluid and it's at the same horizontal plane and there's no barriers. So the pressure here and here is the same. Now pressure from here to here, it's going upwards. Pressure decreases when you go upwards, so it'll be minus 1 feet times the type of fluid unknown, specific gravity of G. And that will equal to, at the end, since it's open to atmospheric, it will equal to 0 gauge. 0 atmospheric gauge. Okay? And that's how you solve it. There's different ways to solving it. They will all give you the same answer if they're correct. But this is how I like to solve it. I like to start from the center point and work my way up and down until I reach the free surface. Okay? Now, how do you go about finding the specific gravity of the specific weight of a unknown a liquid? We only know its specific gravity. Well, specific gravity is a ratio of the liquid of the substance, the specific weight of the substance over the specific weight of water, as we went through that in the first and second lecture. It's also equal to the density of the specific weight of a substance over the density of water at let me double check. At pretty sure it's 4 degrees Celsius or it's 39 degrees Fahrenheit. That's the specific that's the density of water at that temperature, and the specific gravity, the specific weight of water at also 4 degrees Celsius or 39 degrees Fahrenheit. Okay, so if you're given the specific gravity, you can find the specific weight of the substance, or if you're given the density of the substance, you can also find the specific weight. So that won't be an issue. So for our case, we'll be using this, the specific weight of the substance, which is specific weight G, equals to specific gravity of G, which is given, times the specific weight of water at 4 Celsius or 39 Fahrenheit, and that's how you'll get your specific weight of the unknown fluid. You'll insert it here and you'll find the pressure of A. That's it for this class. See you in the next one.